can start recording. All right. Yeah. So this is the one we have done previously, right, at the very end of the session, as I remember. Right, and we discuss about the number systems. And if I recap it, we discussed there are like 4 types of number systems that we are going to learn in this lesson, right? Which is the binary, octal, decimal, and hexadecimal. And decimal is the one we know and we are referring like so far, right? And binary, octal, and hexadecimal, those are something new for us. And we learn about that every number system has a base value, and each and every number system start in its characteristics from the 0 and until 1 less than the base value. So starting from the 0th character, which is the 0, and we'll continue the characters 1 less than the base value. Right, and if you think about number of characters inside a database, inside a number system, it is equals to the base value, right? So binary is having 2 different characters, octal is having 8 different characters, decimal is having 10 different characters, hexadecimal is having 16 different characters. And when we are talking about the hexadecimal, we mentioned something special because because when the characters are continued from 0 to 9, then after if we write 10, there will be a repetition of characters, which is 0 and 1. So because of that, to avoid the repetition of the 0 and 1, or like the characters which we used before, we use capital A, capital B, capital C, D, E, and F to represent what are the values? 11, 12, 13, 14. I'm sorry. My bad. So we are referring A, B, C, D to represent 10, 11, 12, 13, 14, and 15, right? So that is the knowledge that we gained in the last lesson. So today we are going to talk about the conversions, number system conversions, right? So you have to know how to convert your numbers in between the number systems, right? So you can have the heading, or you can have the main heading saying let's take it according to a textbook, right? Let me go for that. Yeah. Before we goes to the number system conversion, we need to know about this most significant bit and the least significant bit, right? So let's first learn about this most significant bit and the least significant bit, right? So here, in general, we talk about most significant value and the least significant value, right? Sometimes we call it number as well, right? So when it comes to the most significant digit and the least significant digit, so this is regarding a particular number, right? But when we talking about the numbers, it can have decimal values, that means the floating point values, dashamagayan kila අපි කියන්නේ, right? Maybe there are integers, right? When it comes to the integers and floating point values, the recognizing the most significant digit and the least significant digit. In short form, we call it MSD, most significant digit, and LSD, least significant digit. There are some ways, right? Now, consider this particular table that is given to you, right? So the number is 329. So in this is an integer, right? No decimal section of the fractional part in here. So the MSD is taken as 3 and LSD is taken as 9. And you can see 3 is at the leftmost place and the 9 is at the rightmost place, right? So in an integer, the most significant digit is the digit that you can find at the leftmost place, right? Where it's not going to be a 0 or like other than the 0, right? And you can find the least significant digit at the very right end, and there is no any rule regarding that, like we have to omit the zeros or not. However, whatever the number, whatever the integer, the rightmost value is going to be the least significant digit, but it is regarding an integer, right? And when it comes to a value which has the fractional parts, right? Let me elaborate it. So I'm talking about most significant digit, which is the MSD, versus least significant digit, which we call the LSD, right? So when you consider an integer, right? Let's say 179. It is an integer. So the most significant digit will be this, which is the 1, and least significant digit will be this, which is the 9. Right? And if you take just one particular value, like 8, so most significant and least significance are going to be the same. 8 is going to be the most significant, as well as 8 is going to be the least significant, because there is only one digit. And if you are going to refer something like this, 0, 2, and be very careful, most significant digit is going to be 2, right? Let me change this as 0, 21. And least significant digit, no change, the one which stays at the very right end, the least significant digit. And if you consider something like this, 210, so the most significant digit is the leftmost value, and least significant digit is still the rightmost value. Now, what we can understand from this, if the number or the value is an integer, most significant digit will be the leftmost value, which is not a zero, right? So in the first case, it is 1. When only single value is there, it is itself. When 0 is there as the leftmost value, we are not considering that as the most significant digit. Instead of that, we consider 2 as the most significant digit. And when it comes to the least significant digit, no difference to an integer, right? It will be the leftmost value. Hi. තේරුණාද මේක? Everyone confirm, did you got that? Everyone, please send me a confirmation message whether you got it or not. Right, great. Okay, right. So let's write about this, neither. A simple note. And before that, let me see whether I have missed anything in the previous. Yeah, no, not much. We get to know about these. And this is just general stuff. Yeah. And people, just confirm, did we write down this unique number base and radix thing? Did we? Not yet, right. Okay, first let's write down that thing. So it is very easy, like for each and every number system, there is a unit, right? So which is the unit is a single object in any particular number system, right? So if you take binary number system, there are 2 units. Octal number system, there are 8 units, likewise, right? And a number, right? So how many, like where we can which we are using to represent an amount, right? And the base. Since we are using different kinds of number system, it's better we indicate the base. Otherwise, we will get confused, right? If you refer 101, when you need to refer different kinds of number systems, so if you just say 101, will not give any idea to which number system that particular number is belongs to. So someone can, if someone think a little bit further, he or she can figure out like this 101, the number 101 can be belongs to many different number systems. Udamya, I'll tell you about it, right? Right. Okay, shall we write this down? So after the, like when you are starting the particular node, yeah, put a star and write these people. You don't need a particular topic because we have wrote the topic already, the number systems. So this is the first point, and it's better you copy it down up to this point, right? Now, Udamya, just hear what I'm saying, like when you are writing. So Udamya is asking a very nice question. In 210, how 0 becomes LSD since there is no value in it, right? So 210, we can find the 0 at the very end. Though it is like we are giving the place values for these things, right? So like 0 represents the 10 to the power 0th value, right? And 1 represents 10 to the power 1 and 2 represents 10 to the power 2, right? So if you get rid of the 0, බිඳුව අමතක කරන්න. බිඳුව අමතක කරොත්, like you are not giving a value to 0 means you can forget the 0. But if you omit the 0, you can't pronounce it as 210, right? 0 එක අමතක කරොත්, then you are going to pronounce it as 21, right? So even though 0 does not have a value, it represents a place, right? So when it comes to the rightmost position, the story differs to it, because that 0 is not giving you any particular what we call a value, right? So that is why the rightmost 0 is taken as a considerable amount. අගයක් තියෙන දෙයක් කියලා අපි සලකන්නේ. Right? So that is why we are taking it is the least significant digit. Right? So we can't say like mathematically 0 does not have any value, but according to the place value, it represents, it helps to form 210. If you forget about that 0, we can't pronounce it as 210. Got it, Dua? Right. Let me know when you are done. All right, one is done. How about others? All right, it seems a lot has done with this. Is there anyone still writing it? Can we move to the other part? Yeah, just indicate me if you are still writing. Right. Okay, we don't really need to go through this. Right. And we know what are the binaries, what are the octals, and what are the hexadecimals, right? Yeah. So now we are on to the most and least significant positional value of a number. Yeah. It's better you write the heading, right? Then I'll tell you what to be written under this. Yeah. Once you're done with the heading, start it from here to here. It is describing about the most and least significant values of a whole number. That means an integer. right? Okay, so once you're done with it, I need you to draw this diagram, right? Do not have this, yeah. Let me know when you are done, people. Okay, one is done. How about others? Okay, seems everyone is done. Is there anyone still writing this? Okay, can we move? I'm going to move this. Is there anyone still writing this? Please indicate. All right. So let's move to the fractional part and look at what they have said. In decimal numbers, the value in the right extreme after the decimal point, which is not zero, becomes the least significant positional value. And the number in the left extreme of the decimal point, which is not a zero, becomes the most significant positional value. Now, it sounds like something very similar, but there is a difference, right? Now, if I take a decimal value or a floating point value, right? Let's say MSD is over here and LSD is over here, right? So if the value is going to be 37.52. This is going to be the most significant digit, and this is going to be the least significant digit, right? So the most significant is going to be the leftmost value, which is not a zero, and least significant digit is going to be the rightmost value, which is not a zero. ඔන්න ඔය point එක හරි වැදගත්. අපි දශම සංඛ්‍යාවක් ගන්නකොට දශම තියෙන සංඛ්‍යාවක් ගත්තම වම් අත පැත්තේ කෙළවරේම බිඳුව නොවන අගය තමයි MSD කියලා අපි අරගන්නේ. LSD එකේදී දකුණු අත පැත්තේ කෙළවරේම බිඳුව නොවන අගය. එතනත් බිඳුව නොවන අගයක් වෙන්නේ. That means if something like this happens, hold on a second, people. Hold on a second. Yeah. Oh. දැන් මෙතන බලන්නකො මේක බලලා යන එක අපිට හොඳයි. Right? Look at here. 1237.0. So the MSD is 1, which is the leftmost value, and the LSD is going to be the 7, which is the rightmost value, which is not a 0. Right? 58.32, same goes there. And look at this, 0.0975. The most significant value is 9. See, leftmost value, which is not a 0. කලින් අපි පාවිච්චි කරපු method එකම තමයි. Right? And 5 is going to be the LSD. In 0.4, again, 4 is going to be the leftmost value, as well as, or like the MSD, most significant digit, as well as the LSD, least significant digit. Right, now if I illustrate it here, so let's take the variations. If it's going to be 3.70. Tesandu, yes, I know you have connected now. Dulapatala, like how many pages we have left? Like one CR page. Can anyone confirm? Like how far we have written only for today? Is it just one CR page or a half of a CR page? How about it? Tesandu, I think yeah, one CR page. Yeah, one CR page. It's better you keep a one CR page, right? Not we didn't write much, but we had this diagram. It's better you have it in a little big manner, right? So if it is 3.7, MSD is going to be 3, the leftmost value, which is not a 0. LSD is going to be 7, rightmost value, which is not a 0. Right? And if we take 0.072, MSD is going to be 7, and LSD is going to be 2. Right? And another one. I could say 45.0. Right? Then MSD is going to be 4, and LSD is going to be 5. right? And let's take another, something like this. What happened if this is there? 250.0. And there you should be very careful, right? Why? MSD is going to be 2 and LSD is going to be this 0. Why is that? In the whole number section, the fractional section එකේ තමයි දකුණු අත පැත්තේ කෙලවරේම එක්කෙනා දකුණු අත පැත්තේ කෙලවරෙන්ම තියෙන බිඳුව නොසලකා හරින්නේ. We omit the 0 of the decimal part, right? The fractional part, but not in the whole number part. 250, it's a whole number. So 2 is going to be the MSD and 0 is going to be the LSD in the 250, not the 0.01, right? And let me give you another, like 0.002. Just මම කියලා දෙන්නම්. right? අපි මේක ඇඳ ගන්න ගමන් මම කියලා දෙන්න පුතේ. ඒවා අඳින්න පටන් ගන්න මේ නෝට් එකක් තියෙනවා ලියන්න. ඒක ලියලා මම කියලා දෙන්නම්. I'm sorry. Right. Okay. Right. Before we comes to this diagram, let's write down how about the fractional part goes. Right. Yeah. So for that, you have to write it from here to here. Right. Write it down. Then let's copy the diagram. Okay, one is done. How about others? No, 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 Damya, you don't. That is why we are having the diagram. You don't need to. You don't need to. Right. Okay, so let's move to the diagram. Seems everyone is done. Okay, this is the one you have to draw. So තෙසඳු අපි මෙතන කතා කරේ මේ නම්බර් එකක පුතා most significant digit කියලා position එකකුයි character එකකුයි least significant digit කියලා character එකක position in values වැඩිම අගයක් තියෙන නම්බර් එක අඩුම අගයක් තියෙන නම්බර් එක කියලා අපි කතා කරේ. So when it comes to the whole numbers or the integers පූර්ණ සංඛ්‍යා ගැන හිතනකොට most significant digit එක කියලා අපි ගත්තේ වම් අත පැත්තේ කෙළවරේම තියෙන බිඳුව නොවන අගය. Right? Integers වල දකුණු අත පැත්තේ කෙළවරේම තියෙන අගය. ඒක බිඳුවක් වුණත් වෙන අගයක් වුණත් ඒක least significant digit කියලා අපි අරගත්තා. ඒක තමයි කලින් diagram එකේ අපි යන්නේ. මෙතන අපි කතා කරන්නේ decimal values තියෙන numbers ගැන. එතනදී most significant digit කියන එකේ concept එක වෙනස් වෙන්නේ නැහැ. වම් අත පැත්තේ බිඳුව නොවන value එක. Right? එතකොට ඕනම value එකක වම් අත පැත්තේ බිඳුව නොවන value එක. හැබැයි කෙළවරේම ඉන්න ඕනේ. කෙළවරේම අගේ හොයන්න ඕනේ. කෙළවරේම කියන බිඳුව නම් ඊට කලින් එකන බලන්න. එයත් බිඳුව නම් ඊට කලින් එකන බලන්න. Right? decimal value එකක least significant digit කියලා කියන්නේ rightmost value එක which is not a zero. decimal value පැත්තට ආවමත් දකුණු අත පැත්තේ කෙළවරේම තියෙන අගය. හැබැයි එතනදී බිඳුව තිබුණොත් බිඳුව අපි සලකන්නේ නැහැ. බිඳුව නොවන දකුණු අත පැත්තේ කෙළවරේම තියෙන අගය. Right? That is why we are given the positions. තේරුණාද සඳු? Right, great. So let me know when you are done this. Okay, one says she has done already. Right. Seems everyone is done. And not everyone. Okay. Are we done, everyone? Is there anyone still writing this? Oh, Tesandu, 250 කියන එකේ පුතා 250 කියන කොටස ඒක පූර්ණ සංඛ්‍යාවක් it's a whole number. So whole number එකක දකුණු අත පැත්තේ කෙළවරේම තියෙන 0 එක can be taken as the least significant digit. Decimal පැත්තට ආවම තමයි zeros අපි නොසලකා හරින්නේ දකුණු අත පැත්තේ කෙළවරේ තියෙන. ඒ කියන්නේ දශම තිතෙන් දකුණු පැත්තේ තියෙන කෙළවරේම තියෙන බිංදු තමයි අපි නොසලකා හරින්නේ. Got it, Tesandu? Right. Okay. So now we know the story about the least significant digit and the most significant digit. So since we are working with decimal values, right? I'm sorry, since we are working with binary values in computing, there are special term called most significant bit and least significant bit. Api computing valadi, we refer ones else or a zero, one or a zero with the name of a bit. Api bit එකක් කියලා කියන්නේ 0 එකකට හරි 1 එකකට හරි. Right? So since the binary numbers are consist of zeros and ones, it is given a special name called most significant bit and least significant bit. This is none other than the same most significant digit and the least significant digit. Same rules are applying, right? But the only difference is since the numbers are using only ones and zeros, digit is renamed as bit, right? So most significant digit is addressed as most significant bit in a binary number, and least significant digit is addressed as least significant bit in a binary number. තේරුණාද? Yes, everyone? Did you got the picture? Right. Okay, let's just mention it out, right? Yeah, write it like this. I'll tell it to you. Put a star and write. Put a star and write. When we considering the values, when we considering the values, of binary number system, its most significant digit is addressed as its most significant digit is addressed as most significant bit. Most significant bit within brackets MSB. MSB. In the same way, in the same way, in the same way, in the same way, yeah, Ravindu, what I was telling is when we considering the binary number system, its most significant digit is addressed as, I think it is the word that I told, is addressed as most significant bit. Most significant bit within brackets MSB. Got it, Ravindu? Okay, then continuing, and in the same way, and in the same way, and in the same way, least significant digit, least significant digit is addressed as, is addressed as is addressed as least significant bit within brackets LSB, least significant bit within brackets LSB. Okay, so under that, just draw this thing. I'll draw it for you. Now we are referring the MSB, most significant bit, and LSB. So I'm not going to write lots of example like the previous one. Let's just mention one or two. So this is going to be MSB, and this is going to be LSB, right? Then 1.01, this is going to be MSB, and this is going to be LSB. And 0101.010. In that, you can say this is MSB, and this is LSB. Udamya, here it's 1010 is a whole number though. So the same rule applies. In the integers, leftmost value, which is not a 0, is going to be the most significant one. And in the rightmost symbol or rightmost character is going to be the least significant one. Purna sankhyaවක් නේදුව. Right? If it is a decimal value, then the rightmost 0 can be omitted. Like the same thing happens here in 250. මේ 210 කියලා අපි ලියලා 0 වරගත්තේ. මෙතන 0 අරගත්ත හේතුවම තමයි මෙතන 0 අරගන්නෙත්. Got that දුව? Clear නැත්තම් කියන්න, right? Okay. Right. All right. So I think everyone is done with this MSB and LSB representation. So let's move. Right. So there are some activities. Yes, people, can we have the answers for this? Just type it on the chat. I'll tell you whether it is correct or wrong. They are asking the MSB and LSB. Sulakti, first one is correct. Udamya, first one is correct. Ravindu, first one is correct. Sulakti, second one is correct. Dinelka, first one is correct. Behara, first one is correct. Tesandu, yeah, I hope this is the answer for the first one. Yeah, it is correct. Dinelka, second one is correct. Udamya, second one is correct. Behara, second one is correct. Sulakdi, second one is correct. Osanda, is that for the first one, Puta? Ravindu? Right, Osanda, that is correct. Ravindu, this is for to which one? LSB is 0. Tesandu, second one is correct. Ravindu, okay. LSB is okay. Put the question number and send me the answers. Behara, yes, the third one is correct. Well done. Sulakti, yes, fourth one is correct. Well done. Tesandu, third one is correct. Well done. Dinelka, yeah, you are super fast. Right, okay, yes, third one is correct. Fourth one is correct. Fifth one is correct as well. Good, good, good. Behara, fourth one is correct. Sulakdi, fifth one is correct. Ravindu, second one is correct. Pehara, fifth one is correct. Well done. Osan, the second one is correct. Good. Ravindu, third one is correct. Tesandu, fourth one is correct. Osan, the third one is correct. Ravindu, fourth one is correct. Tesandu, fifth one is correct. Well done. Well done. Right. Osanda, yes. Fourth one is correct. Right. Okay. I hope most of you have answered that. So there are some people who haven't sent me the answers. Yeah. Methul, Imasha, Januki, you haven't sent me the answers. Sasandi, Sayuri, Senya. Right. Yeah. Sayuri. Yes, that is correct. Well done. Okay. Others, you should send me the answers, right? As a WhatsApp message, right? I'm moving to the next part of the lesson. Right, here we go. Now we are going to talk about the conversions, right? So let's have the heading saying conversions between number systems. Right. So there you have to do some work and some practice to have this idea, because there will be conversions in your exam paper, in the MCQs, in the short answer question, right? So you have to get ready. Okay. Right. Now hear me out. Now, when it comes to the conversions, there are 4 types of conversions that we are going to do. What are these 4 types? The first type is converting decimal values into the non-decimal number system values. Right? So in our case, we are going to convert decimal into binary, decimal into octal, decimal into hexadecimal. So the way you are going to do all 3 conversions, it has the very same technique. So what you have to do is you have to learn the technique, right? That's all you have to do. And the second conversion is the reverse of these things. So that means non-decimal numbers will be converted into decimal numbers, right? So the reverse of the first one. Again, those 3 conversions will have a one particular technique. So learn the technique, right? And as the third conversion, we are going to convert binary numbers into octal and into hexadecimal. Again, one particular technique is there. And the fourth one is the reverse of the third. Octal and hexadecimal values will be converted into the binaries. Again, it has a very same way of doing those, right? People, just a second, just a second. Yeah, Tesandu, I was running into something since there is a sudden rain, right? So that's why I muted it, right? Not because I was talking, muting the mic. Right, so as I told you, these four techniques are there. So we are going to learn one technique at a time, and we are going to do some maths, right? To get practice with this thing, right? Okay, so why don't you draw this? I'll write the headings at the bottom, right? So do the heading conversion between number systems. So I'll put the headings at the below, right? Udamya, you can just write down this thing. I just clarify what are the conversions that we have to do. So write what you can see on the screen. No, Tesandu. No, Puta. We are not doing the binary into decimal because we are doing it on the second one, Puta. Binary ka decimal karne ka api second ke karanawane. So we don't need to do it on the third. Right? Okay. Are we done with this? Okay, Ravidu. Keep doing, keep doing. Okay, are we done? Okay. Ravindu, do you got a problem? Or you are done? Okay, okay, okay. Yes, answer comes with two messages, right? Okay, right, okay, right, okay, no problem. Right. Now, the first conversion, decimal to non-decimal conversion, right? So, number one, decimal to non-decimal conversion. Right. Now, learn the technique. Right. Now, hear me out clearly, right? So, the first example that I'm taking is I'm giving the binary value 27. I'm sorry, the decimal value 27 needs to be converted into its binary equivalent. Right? 27 decimal number needs to be converted into a binary equivalent. Right? So this is the way that we are going to do. Since we are converting decimal into binary, right? Decimal into binary, decimal into a non-decimal number system. We take the decimal value, and we are going to divide it by 2. Why we are dividing it by 2? It is because we are converting it to a binary value, right? We are dividing this because we are converting into a binary, right? So how we are going to do this? You are going to divide this by 2. So once you divide it by 2, it's going to be 1. And for 7, there will be 3. And 13 into 2 means 26. So 1 is remaining. That particular remaining should write by putting a dash. Right? Irak gahala ekka කියලා ලියන්න ඕනේ. Right? And what is this? This is the remainder after division. ඕක තේරුණාද? Yes? Right. Now our task is not over. We have to divide this. We have to divide this until your answer, right now, in this division, answer is 13. 1 is remaining, right? So you have to do the division by the same value, that means 2, until you are receiving a value less than 2. අපි බෙදන්නේ දෙකෙන්නේ. දෙකට වඩා අඩු අගයක් උත්තරයට එනකන් අපි මේක බෙදන්න ඕන. තව ක්‍රමයක් තියෙනවා බිඳුව වෙනකන් බෙදන්න ඕනේ කියලා මම ඒකත් පෙන්නන්නම්. right? මම කියලා දෙන ක්‍රමේ short කියලා කියන්නේ කලින් ඉවර වෙනවා. right? So 13 is not something less than 2. So what you are going to do is you are going to divide this again by what? By 2. Reason is we are converting the decimal value into the binary. So when we divide it by 2, the answer is going to be 6. And again, 1 is remaining. So again, 6 is not something less than 2. So we are divided by 2 again. So then it gives the answer as 3. This time, nothing is remaining. But nothing remaining means you can omit the remainder value. You can't omit the remainder value. You have to say, okay, nothing is remaining. It's a 0. තියෙනවා කියලා ලියලා පෙන්නන්න ඕනේ. 0 අමතක කරන්න බෑ. Now still 3 is not less than 2. Right? Less than 2 කියලා කියන්නේ 1 හම්බෙන්න ඕනේ. Right? දෙක ආවත් අපි දෙකක් බෙදන්න ඕනේ දෙකෙන්. මොකද දෙක කියන්නේ දෙකට වඩා අඩු වගයක් නෙවෙයි. Right? So 3 is not less than 2 anyway. So we are going to divide it by 2 again. Right? Which is going to give you 1 as the answer and 1 is remaining. Right? මෙතනට වෙනකන් කරපු විදිය තේරුණාද? Just confirm, people. Right, great. Now we have found something less than 2. So we stop the dividing. And what we are going to do, from the place we have stopped, start from the place we have stopped and consider the remainders and write to the top of the remainders. Start from the place we have stopped. Consider the remainders from bottom to top. That means your binary equivalent is going to come like 1, it is where the place we stop, then another 1, then a 0, then 1, then another 1. So like starting from this point, then this, then this, then this, and finally this is going to write. So the base is going to be 2. This is how we are going to convert a decimal value into its binary. Did you got this? Yes, everyone? Did you get this? So simple, right? Okay. So shall we write it down? So started from here, decimal to non-decimal conversion, and copy it to your book. Right, if you are done with the writing, you can disconnect, right? So thank you very much for today, and we are going to continue the conversions to the next week as well, right? We have to do some mathematics regarding this, right? Let's learn it slowly. Right, Tesandu, if you have finished it, you can disconnect, Buddha. Thank you very much.
Thank you, sir.
Right, okay. Have a very nice weekend, people, right? And be safe, right? Right, thank you, everyone. Thank you very much. Be safe, everyone. I'm going to end the session from here. And Januki, are you still writing the work? I have stopped the sharing. And Mithul, Januki and Mithul, are you still writing?